we're going to multiply polynomials. It'll start out kind of slowly by multiplying monomials, and then we'll build that up to a monomial times a polynomial, and finally product of binomials, and then binomials and trinomials. So we'll start out simply with product of two monomials. Problem number 16 is negative 2a cubed times 11a to the second. Now for this first one, I'll kind of do this in slow motion, but the rest of these I think we'll kind of do a little bit faster. Hold on. I'm going to rewrite this as negative 2 times 11 times a to the third times a to the second. And all I'm doing is I'm using the commutative properties of multiplication to rearrange these things. All right. Now I'm ready for your answer. What do we get when we multiply this again? Minus 22. Yes, good. You add those together. Now what I expect most of us to do is just kind of do this part in our head. Just say, okay, well, let's multiply the numbers together. That's great. And then multiply the variables together. So on your papers, I expect you to go from here to here. If you want to stop there in the middle, ponder it that way, that's fine. Nothing wrong with that. But in general, we're just going to kind of do it right from here. Let's see if we can do that. If it works out well for us, negative 5x cubed y to the 6th power multiplied by 2x cubed y to the 2nd power. That's the same kind of thing happening here that happened in our last one. We're going to multiply things together that kind of go together. For instance, the negative 5 and the 2. What do we get? Negative 10, good. Add the exponents, thank you. X to the 6. How about the y's? Y to the 8th, yes. And that's it. Now, we'll do one last one like this, and then we'll start bumping things up slowly but surely. Problem number 24, negative 2/3 x to the 6 times 9x cubed. Well, this is where you guys are going to struggle a little bit. Let's see. We're going to have to multiply the 2/3, negative 2/3 times the 9. So let me do that here. Instead of thinking of it as 9, maybe I'll think of it as 9 over 1. And you're right. The reason I want you to do that is so that you'll cancel. I don't want you to multiply and get negative 18 over 3. I want you to cancel. So where's the cancellation? 9 and 3. 3 goes into 3 once, and into 3, and into 9 3 times. So negative 6. Negative 6, x to what power? 9. X to the 9. Nice. So all that one took was a little extra care with multiplying the coefficients. We're going to start expanding things a little bit. Instead of a monomial times a monomial, let's do a monomial times a trinomial. Negative 4b cubed multiplied by 2b squared minus 2b plus 2. What's understood to be here in terms of multiplication? What do we have to do?
We have to multiply minus 4b by the parentheses, everything inside the parentheses.
Good. This term has to distribute itself to every term in the parentheses. So let's start with the first one. Jess, maybe you can help me with the first one. Negative 4b cubed times 2b squared. Good. Negative 8b to the 5th. Let's see. Jenna. How about the next one? Good, plus 8b to the fourth. Casanea, sorry. How about the last one? Good, negative 8b to the third. Notice that this last one, there's no b to the third times something. There's no like terms here, so just leave it there. 8b to the third. Yeah, looks good. Thank you, folks. Yes, that's it. There's no like terms. We can't combine anything else, so yeah, we're done with that one. No, that's as much as I would want out of a problem like this. Now, what's going to happen later, if you're curious, is that you're going to start out with problems like this, and then sometimes you're going to factor them. So you're going to do the opposite of what we just did. So you might look at this and say, gee, there's a common factor. I can factor it out. But right now, the idea is just to distribute here. So I appreciate the questions, though. Okay. Problem 40. Suppose I wanted to find the area of the rectangle shown in problem number 40. I'm just going to draw that for ourselves here. So the one side has a distance that's W yards, and the other side has a distance that's 8W plus 1 yards. How would you find the area of a rectangle? Yeah. The area of a rectangle is just the width times the height, or the width times the length. It's just the product of these two sides. So the area is going to equal W times 8W plus 1. Can someone distribute that for me? Good. Now the units, when you have area, your units are always going to be squared. So you can write square yards like that, SQ yards, or you could also write, and even though it kind of bothers me mathematically, you can write yards squared like that, but it represents an area, square units. Either of them, yeah. You don't have to do both, just do one. So we've multiplied a monomial times a monomial times a trinomial, monomial times a binomial. Finally, let's get around to multiplying binomials. So that process is going to take us into a new phase. Maybe it's something that you've heard of before. Yeah. Soon to be your second favorite four-letter F word. Of course, the first one is free, right? All right, got to get that in there before I get in trouble. We're going to use this to multiply binomials. Problem number 58. X minus 5. Oops, not 58, sorry. How about 42? We'll get around to 58. We'll start with 42, though. A plus 4 times A plus 5. And really, this is a case of distributing just like we did with the previous problems. The number that's out in front here, or this first term here, has to multiply each of the terms here. So there's going to be a times a, and then a times 5. So what's a times a going to give me? A squared. And then a times 5. Yeah. I like that you write it as 5a, not a times 5. Now, the same thing has to happen with the 4. It has to distribute itself to both of those terms. Plus 4a plus 20. Don't leave it like this. There's like terms that you should combine. A squared plus 9a. There you go. Now there's a different way, well, there's a way you can think of this and help remind yourself of how to multiply these things. These first two multiplications are the result of multiplying the first terms together. And then we multiply the outside terms together. And then the inside terms together. And then the last terms together. First, outside, inside, last. Doing that allows you to multiply two binomials. Don't try and use it when you're multiplying a binomial times a trinomial. You'll run out of letters. Okay, it only works for binomial times binomial. All right, I'd like you to do a bunch. Problem number 44, 46, and 48. 44, 46, 48. So n plus 8, n minus 10. 46 is 3x minus 4 times x plus 5. And last, 48. Let's see. N 48. Yeah, 48. 5x minus 3 times 2x minus 3. Now let me give you some incentive to help each other out and get through these quickly and correctly. After this, we've got 4 or 5 more problems to do. So we can actually get out early depending on how fast you guys get through these. Help each other out. Make sure you got them right. This is a 5 in case that's not clear. N plus 8 minus, or times n minus 10. So as we FOIL this out, we'll get n squared minus 10n plus 8n minus 80. Combining like terms, I get n squared minus 2n minus 80. So, yay. Got that one down. One down, two to go here. Distributing here, 3x squared. Outside would be plus 15x. Inside is minus 4x minus 20. Combining like terms, what do I get? Thank you. 3x squared plus 11x minus 20. And last but not least, 10x squared. All right. Good. Again, combine like terms to get that last one. There's one last variety of problems that you'll see in this section, and it's going to be a binomial times a trinomial. I'll give you a couple examples. There's a little bit of a trick here in doing this that'll make your life a lot easier when you try and simplify it all at the end. Now, it's not the only way you can do these things. It's just my suggestion. I found that it works pretty easy. Now, if you wanted to come up with a word to help you remember how to multiply these things, you're going to need a word that has 6 letters. Because you have this x here has to multiply each of these 3. This negative 5 here has to multiply each of those 3. So that's 6 multiplications. Yes, sir?
Can we do like every one of these like x times all like the other side and 5
Yeah.
times the other side, every one of them by parentheses?
You can.
Just not to have problems in the numbers.
Well, let's take a look at what I'm going to do here. I'm going to take the x and multiply it by each of those things here. So x times x squared is x cubed. And then x times 2x is a plus 2x squared. And finally a minus 3x. So I distributed the x. Now I got to distribute the minus 5. And here's where you can be a little bit clever in your work. When I distribute the minus 5, what do we get? Minus 5 times x squared gives you negative 5x squared. Let's write it right here. Why am I writing it right there? Exactly. So they line up. It's easier. Minus 5x squared minus 10x plus 15. Now notice the last one doesn't line up with anything, but you know what? That's okay. I just put it over here. If I combine like terms, I get x cubed minus 3x squared minus 13x plus 15. Yay. I'll give you one to try like this, and then we can be done. So it's problem number 60. Last one was 58. Three x plus 1 multiplied by 2x squared minus 3x plus 1. Okay, so we multiply the first two. 6x cubed
minus 9x squared
minus 9x squared
plus
plus 3x. And then we're going to distribute the 1 to all three terms. And that's pretty easy, right? Multiplying by 1. 2x squared.
minus 3x plus 1.
When we add these, we get 6x cubed. I'd be happiest if you just left it blank here. You don't have to write 0x. That's good enough for me, is just leave it blank. For homework, try 13 through 69. Should take you less time than it does a political debate to turn ugly. So good luck with that. See ya.